So if you graph this one, there's three graphs. The square root of x, 0, which is the x-axis, and then the linear y equals x minus 2. So I color-coded them red, blue, and black. Here's my question, though. If you put it into the calculator, right, you see, if you put it in the calculator, you would get 5.3 as an answer. 5.33333 forever, right? Why is that answer wrong? That answer is wrong. Why? Do you guys know?
Because the line for y equals x minus 2 blocks off some of it.
Yes. So if this is what I forgot, this is the reason I put this on here, because this one's kind of it's not a sneaky one, but it's, if you don't look at the picture carefully, you will get it wrong. Because you're like, oh, top minus bottom. The curve, the square root is the top. The line, x minus 2 is the bottom, right? There's a problem there, though, right? There's a problem. Oh, I don't need the key. You can give Pam back the key. There you go.
Thank you.
Uh-huh. Okay. There's a problem there, though. The red is definitely a top, but the black isn't the bottom all the time, right? Because if the black is the top, or sorry, the red is the top from here to here, right? The whole way across the green. But the black is only the bottom from here to here, right? The blue is the bottom from here to here. So if you're going top to bottom, you have to break this up into smaller pieces. You have to break this up into, let's see, let me use a different color. So not only, you're going to have two regions to do it correctly, R1 and R2. Because this region, R1, the top is the red, the square root, the bottom is the x-axis. The other part, the top is the square root, the bottom is x minus 2. So it's two different pieces that you have to find area of and add them together. Again, without the picture, you would have never known that. Without the picture, you would have never known that. So that's why, another reason why picture is extremely important when you're looking at these. So we have to set up two separate integrals, one for R1 and one for R2. One for R1 and one for R2. So R1, the top bound is square root of x minus the bottom. For R1, the bottom is y equals 0. The bottom is going to be y equals 0. So you just put 0, or you don't need actually to put 0 because, right? The hard part is, not the hard part, but the more difficult part is the bounds. How do we find the bounds? How do we find the bounds of R1? Yes, you set the square root of x and 0 equal to each other. What's the easiest way to find that? What's the easiest way to find the two bounds? What's special about that?
Look at where they intersect.
What looks at what intersects? We got three things. We got blue, red, and black. What intersect?
Where blue and black intersect.
Where blue and black intersect, right here. Yeah, blue and black. So we got to figure out where blue and black intersects. Right? Is that a whole number? Is it not a whole number? It doesn't look like a whole number, but my graph is not drawn to scale. These aren't, so it's just more of a sketch. So you got to figure out where that is first. Okay, that's the first thing you got to do. R2, is red is top. So that's square root of x minus, now black is the bottom. Black is the bottom, which is x minus 2. dx. You have to find the bounds for R2. Well, it's going to share a bound with R1. So once you find this guy, you're good there. But then you got to find out where black and red intersect. Okay, so do that. And then we're going to add those two guys together. And we'll get R1 plus R2. Okay, so use your calculator to figure out those guys. So the bounds for R1 are 0 to 2, because that's where the bounds for x are. And then it picks up for R2, it picks up 2, and then they cross at 4, 2, 4. So once you get the bounds, you plug it in, and it is smaller. This guy right here, this answer, the original answer took into account all of this too. That's not the part we want. We don't want that part. Because if I did top minus bottom, this is going to be the top. This is always be the bottom. So it covers actually all of this. Actually, it covers all, sorry, this part here. It covers all of this. That's what this guy did. That's not what I want, right? That's too much. This guy covers R1 and R2, which is less. So it's about 2 units less, about 2 units squared less that I wanted. Okay? That's why a picture is important. A picture is extremely important, whether you're looking at it on a graph or whether you're looking at it, whether you draw the graph. This could be the difference between, and guess what? On a multiple choice, that answer will be there every time. Every time that answer will be there because they know where students make mistakes. They know where mistakes are made. Okay? All right, so the last part of this. Sometimes we're given equations that are in terms of y. So that means solved for x. Sometimes we're given equations that are solved for x in terms of y. Or it will be easier to calculate the area if the functions are in terms of y. In either case, the steps are similar, except that we integrate from bottom to top instead of from left to right. So now you're going to look at things that look like, let's see if I can find a picture of one. Actually, you know what? Let's just do number 1. Let's just do, or example number 6. You'll see it. Okay. Find the area between the curve. Find the area of the region and the bound. So now we have to have a picture. On your calculator, try graphing those guys. On your calculator, graph those 3 guys and see what you get. Just graph them. Get a picture. If you have a graph in front of you, you did something wrong. You shouldn't have a graph in front of you. Why shouldn't I have a graph in front of me if I use the calculator? because you need to solve for y. You need to solve for y. Calculator doesn't, you can't put x equals. Calculator needs y equals, y equals, y equals, y equals. So if you put x squared in there, it'll give you a parabola. That's not the graph. This guy right here is not a parabola. Okay? This guy right here is not a straight line, or they're not the straight lines you think. Calculator can't do these. Okay? The calculator is not able to. Even if you were to solve this one for y, it wouldn't be able to do it. Because if you solved it for y, took the square root, it would only give you half the graph. It wouldn't give you the full graph. So we have to do these by hand. These guys right here, we have to do by hand because our calculator doesn't do it. Simple as that. If our calculator can't do it, we can't do it. We can't use it. So, graph them by hand. So one's easy, y equals 0, that's just the x-axis. How do I graph the first one? How do I graph this guy here? That's the way, yeah. So if you don't know how to graph it, that's the only way to do it. Make an x and a y table. Make an x and a y table. That's the only way I know how to graph it. If I don't know another method, set up an x and a y table. They got an x and a y, set up an x and a y table. Unless you know what this graph looks like. This graph's a pretty basic graph. If you know what it looks like, then you don't need an x and a y table. But if you have no clue what this guy looks like, then you got to use an x and a y table. Okay? So x and y. What do we do now? What do we do now? Mm-hmm. Plug in value y. Don't we plug in values for x? Don't we plug in numbers here? But it's flipped. This is not a normal equation, right? This is solved for x. So in that case, we do have to pick numbers for y, right? We do have to pick numbers for y. So pick numbers for y, any numbers you want. I'd keep them small, just so that you don't have big graph. Okay. 1, 2, 3, 4. 1, 2, 1, 2. Let's see. 4, -2. It might look, this graph might look familiar, but it's probably something you're not used to seeing. It kind of looks like a parabola on its side, but it's not a parabola. This is not a parabola. Parabolas only have arrows up or arrows down. So it looks like a parabola. It does look similar to a parabola, but it is not a parabola. We don't call this a parabola. This is a conic. Okay. So saying this is a parabola is not correct. Saying it looks like a parabola is okay. It does look like a parabola. If I kind of turn my head to the side, it looks like a parabola. But parabolas only go arrows up and arrows down. Okay, so that we got that guy. The next guy. It's solved for x. So we plug in numbers for y. Any numbers you want. -2, -1, 0, 1, 2. This guy looks linear. Okay. So 0, -2. 1, -1. 2, 0. 3, 1. 4, 2. Oops. Let's see, the graph's not really drawn to scale, so let me fix it a little bit. Okay, there we go. Okay. So the area bounded by those regions. Find the area in the first quadrant. So it has to only be in the first quadrant. Bounded. So cut off. So we look here. All of this right here, all of this is bounded by all of them, right? But they only want first quadrant. So they only want first quadrant. So we just want this area here. R1. So now we have to find bounds. So R1 equals, but our graph is in terms of x equals. We're speaking in terms of y, right? So we're speaking in terms of y. So I can't put y squared, y. I can't put y's in here. Unless I use this guy here. So now we're going to speak in terms of y. Now it's not dx anymore, it's dy. So to do that, we don't look at top minus bottom anymore. We look at right minus left. Right minus left. So if I were to look in this area here, in the green, which guy is on the right and which guy is on the left? Just in the green. I don't care about anything else, just the green. So you're just focused on this area here, the green. So in the green, which one's on the right and which one's on the left? Which color? Just tell me the color. Mm-hmm.
Black and red.
Black is on the right, red is on the left. Okay? So black is y plus 2. So y plus 2 minus. Red is y squared. dy. Now we need the bounds. Where are the bounds going to be here? Where it gets a little tricky. Mm-hmm. The x-axis, yes, the x-axis will count as 1. This will count as 1. Oops, wrong color. The x-axis will count as 1. Where's the other one?
I might go out on the limb here and say where red and black intersect at.
So right here?
Yes. I could be wrong.
Take a look at it. Aren't the bounds here and here? So it looks like 0 and 4, right?
Yeah.
If I put that, that would be wrong. Why?
Because we're looking in terms of y, not in terms of x.
Yeah, if you're looking at it with the straight, if you're looking at it like this, you're looking at it the wrong way. You need to tilt your head to the side. I can't do that on mine, but you can just turn your paper to the side. So when you have your paper, turn your paper to the side. Oops, I can't do that to mine, but it won't allow me to do it to mine. But you turn your paper to the side. Now the bounds are going like this. So once you turn your paper to the side, what are the left and what is the right?
0 to 2.
So 0 to 2. That's the bounds, 0 to 2. The y's are the bounds when we're in terms of y. So 0 to 2. Once you do this, your calculator can do this. Once you give it this, your calculator's okay doing it. Okay? Your calculator won't be able to graph them, but it will be able to do this. Just change the y's to x's, and your calculator can do this part. And you get 3.3333333 forever. Okay. Even if this was a non-calculator question, you could still do it by hand. It's not hard to do it by hand. Okay. All right. I want you to do number 7. I want you to do number 7. Using your calculator. You can use your calculator on this one. So you have 2 options with this graph here. You have 2 options. First, you can do top to bottom. Right? This guy is top, but bottom is only from here to here, right? And then it's of itself, right? Top and bottom's here. So that one might not be, and plus, there is no way you can plug this guy into your calculator and expect it to do anything with that. Your calculator will just say nope. Or if it does give you an answer, it's wrong. Because this is solved. Even if you solve for x or y, so even if you add 2 to both sides and take the square root, it won't give you the same answer. If you were to graph this in your calculator, if you were to solve for y, add 2 to both sides, take the square root, you would get the square root of x plus 2, I believe. That would only give you half the answer. It would give you the bottom, and we need the bottom. So top minus bottom is not looking like it's going to be the best way here. But I do have a right and I do have a left. The red for the green part, I'm only talking about the green. In the green part, it looks like the red is the right and the blue is the left. Okay? That's looking like a better solution to get the area in there. So the right problem is, if I put the right is x cubed. The left is y squared minus 2. How do I put that in my calculator? The answer is you don't put that in your calculator. You can't put that in your calculator. So what do I need to do?
You could take the square root of y, or cube root of y.
Cube root of y. So y equals x cubed. So I take the cube root of y. Do I need a plus and a minus in front of the cube root? Why not? Why do I not need? Because when I take square roots, I always have to have a plus and a minus, right? Why do I not need a plus or a minus in front of the cube root? So like, for example, if I'm solving x squared equals 16, right? And I take the square root of both sides, my answer is plus and minus 4, right? My question is, do I need that for this guy here? And if I do, how in the world does my calculator do plus and minus?
Just because it's odd.
Yeah, say it. Go Ash, say it. What?
It's because it's odd.
It's odd. Because it's odd, the sign, can I have negatives under here?
Yes.
Yeah. Can I have negatives over here? No. That's where I can't. So second power, or second root, square root, fourth root, sixth root, eighth root, got to have plus and minus. First root, third root, fifth root, seventh root, you don't have to have plus and minus. Makes it a lot easier when I'm putting it in my calculator. Okay? So this guy I'm going to put in. Third root y. Good there, dy. Okay? Happy there. Bounds. Now I have to find bounds. Since I'm using y, the bounds aren't going to be left and right. They're going to be top and bottom, right? They're going to be top and bottom. So the bounds I'm looking for are 2. Let me use a different color so we can distinguish that. This guy right here in orange and this guy right here in orange, right? Those are the 2 bounds. So I need to find those. Again, I can't use a calculator because it won't graph the blue guy. My calculator won't graph the blue guy. It'll graph the red guy, but it won't graph the blue guy. So what's another way of finding these dots here? What's a way of doing it by hand?
We set cube root of y and y squared minus 2 equal to each other.
Are we trying to find where they're the same?
Yes.
Then we do that, right? If we're trying to find out where they're the same, we do that. So here's my question. Where do I plug it in? Do I say x cubed equals y squared minus 2? I can't do that, right? So how do I set those equal to each other? Right? Back earlier, when we did number 1, we set them both equal to each other, right? Because they were both y equals, right? F of x and g of x are the same as y. But now I have one that says x and one that says y. So how do I set those? There is a way. It's not there is a way, but you have to do it correctly, or else you won't do it. You won't get the right answer. How do I set those equal to each other?
Is it cube root of 1 equals y squared minus 2?
Where'd you get that?
The cube root of y is when
The-
I took the cube root of both sides of y, x cubed, but then again I could be wrong.
No, I'm just asking where you got them. So look at these guys here. They both say x equals, right? So if they both say x equals, if they're both equal to x, aren't they by rule have to be equal to each other? Right? So we set those up. Cube root. How do I solve these guys? How do I solve this? I need to solve for what? Again, this is not a calculus question. This is a prerequisite question. So you guys should have some idea about how to solve it. How would I solve this?
Cube both sides.
Okay, let's cube both sides. See. Okay. So I get y equals y squared minus 2 cubed. Is that my answer?
Not yet.
No, because I have y's on both sides, right? So what would be my how would I solve for what? There is an easier way to do this, but I'm not going to tell you. If you can tell me, I'll do it. But there is an easier way to do this.
Subtract y on both sides.
I could subtract y on both sides. Yeah, this is the harder way. This is the harder way to do it. This is the harder way to go. You could get your answer, subtract y from both sides, and then I would have to do this guy over here. So I'd have to multiply it out 3 times, and I'd get y to the 6th power. You could do it that way. That way would work. But there's an easier way. I'm trying to find these two guys, right? I'm trying to find these two guys. One of them's really easy, and one of them, well, they're both kind of easy. You just got to think about it. Look at this dot right here. So I put the yellow dot or the orange dot because that's where I need to find the bound, right? But what's under it? There's 2 things under it. What's under it? I made this orange because this is where I need to find the bounds. But before that, there were 2 things under that. What's under this guy? You can almost see one. You can almost see what's under it. What's underneath the orange dots?
Blue and red dot.
It's a blue dot, and underneath that is a red dot. How do I know that? It's because I made the graph. If you made the graph, you know that because you made the dots. There was a blue dot, -1, -1. And when I graph this guy, there is -1, -1. There's a blue dot and there's a red dot. So because of that, they both cross here. So what's the bound here?
-1.
-1. All right. Okay. You don't want me to tell you the answers, because if I have to tell you the answers, you're going to get one like this on the test, but except harder. Okay? So if you know the answers, by all means, please help out in the discussion, okay? So now we got that. So now how do we get this guy here?
May I just comment that this may be a little bit slightly more difficult?
Doesn't matter. We know how do we get this guy? That's all I want. How do I get that guy there? That's all I care about. How do I get that guy there? Hard, easy, medium way, it don't matter. How do we get this guy right here? Bell's going to ring, and I'm not going to tell you. So if we plug in 1 to x equals y squared, it's x squared minus 2, so that won't work. We need to find out where 1 is on both. It involves using the calculator. We'll stop right there for